In Bargadiya Purwa microgrid implementation, we have installed 30 kW biomass system, 30 kW solar PV, hybrid inverter along with 100 kWh of battery energy storage system. And this microgrid implementation is connected with other microgrid implemented via AC-DC-AC converter for power sharing. Now, we will be explaining the different modes of operation of Bargadiya Purwa microgrid. If the grid power supply is available, the load of the village hamlet Bargadiya Purwa will be supplied by the available solar PV generation. If the PV solar generation exceeds the demand of Bargadiya Purwa and the battery system is not fully charged, the microgrid controller will use this excess solar PV generation to charge the battery system. The biomass system will work as a standalone unit to provide power during the night, evening hours based on the availability of gas. When the biomass generator is supplying power to the load side, the hybrid inverter will be shut down. If the battery storage system of Bargadiya Purwa is fully charged and there is still excess solar energy, it will be verified by the microgrid controller whether there is a lack of energy at the neighbor village hamlet Chabba Nevada. If this is the case, the AC-DC-AC converter between both villages will be utilized by the microgrid controller to export the solar excess energy from Bargadiya Purwa to Chabba Nevada. If the battery storage system of Bargadiya Purwa is fully charged and there is no lack of energy at the neighboring village hamlet Chabba Nevada, the remaining excess solar energy of Bargadiya Purwa will be exported to the grid. If the load of Bargadiya Purwa exceeds the solar generation, the remaining power will be supplied by the AC-DC-AC converter system and the battery storage system as long as the energy storage system contains sufficient energy capacities in order to keep the frequency and voltage of the microgrid within the foreseen limits. If the load of Bargadiya Purwa exceeds the solar, AC-DC-AC converter system and the energy storage system run out of energy, the storage system will be disconnected in order to keep some energy for a later restart of the system. The PV inverters will trip in this case because they have no grid forming ability. If enough solar irradiation and biogas is available, the biogas system performs a black start, PV inverters will connect and will supply power to the load bus of Bargadiya Purwa. During this operation, the hybrid inverter will be switched off. If the solar generation exceeds the load of Bargadiya Purwa, the energy storage system of Bargadiya Purwa will be charged as long as the energy storage system is not fully charged in order to keep the frequency and voltage of the microgrid within the foreseen limits. If the solar generation exceeds the load of Bargadiya Purwa and the energy storage system of Bargadiya Purwa is nearly fully charged, it will be checked by the microgrid controller whether this surplus of energy can be utilized via the AC-DC-AC connection for the village hamlet Chabba Nevada. If this is the case, as much as power, up to 25 kilowatts, will be transferred via the AC-DC-AC connection to Chabba Nevada in order to balance the demand and generation for Bargadiya Purwa. In case there is still no grid supply and the microgrid of Bargadiya Purwa was down due to a lack of power for the microgrid controller regularly checks whether the PV generation potential increases, if the solar potential rises. The energy storage system will be switched on in order to perform black start of the grid, by re-establishing the foreseen frequency and voltage level. As soon as the battery storage system has performed a black start and run within grid forming mode, the PV inverters automatically reconnect with the AC generation distribution board and provide PV power to the battery system.